going to put on recording, then we can start, okay. Okay, so we will continue our discussion about model building. And last class, we also kind of get some very initial idea about this studies models package. And so this can be used for model building. And there is another one, it's sklearn. So that's most used for machine learning to prediction. And for this one, you can get some idea about the data's statistic features, okay, like for regression, and using regression, you can kind of get the idea about the importance of the independent variables, okay. And last class, I remember we saw an example about statistic models. And last class, we also saw the example, discussed the idea about the interface that between the data and the number. We use the PATSI that package. So that's what we discussed yesterday. So we will take a look more about this statistics model and sklearn today. So first, and yesterday, last class, we already discussed this. So whenever you want to use the statistics model to do some statistic analysis, for example, the regression, then you need to import it, okay? So we can import the API, we can also import formula API, okay? And the next part, so this part, this function, it's just to try to use, try to generate some data, okay, based on the size of the data that you specify, okay, with some random normal distribution data, is it? So over here you want to build the data around a certain mean with certain variance, okay, and you can specify the size. And if we specify size as 3, is it? Then it's the number is going to be generated uses the random normal distribution random number generated 3 numbers, okay. And so we are going to use this defined method that to generate the numbers. And over here, the number later on we will see is 100. Yeah, so n is defined as 100. So you are going to generate, so the idea over here, the x, is it because it's, we are going to try to do linear regression. And the linear regression generally is y equals like a plus bx, is it? And x is independent, independent variables, is it? And this is dependent variables, is it? And if we plug in the formula, it will find the coefficient A and B for us, is it? And the x, it's not just a single, it can be multiple variables, is it? And over here, you are going to use samples. So a number of x values and the corresponding y values, is it? The samples. And try to find the best fit A and B is a coefficient. Then you're going to use the coefficient as the coefficient for this formula so that you can do the linear regression. Okay, and here, how many samples we are going to have? We are going to have 100 samples. Okay, and it has 3 columns. So basically, it's going to have x1, x2, and x3. So 3 independent variables, and you have 100 samples. Okay, that's what this example try to do. Okay, try to do. And then anyway, so we can take a pick of the first 5 numbers, x and y values. And then for this case, for our x, we also add some constant, okay, color. And so this is from the statistics model. The statistics model, and if you want to add constant, to the existing matrix, that independent variables, samples, then you can call the add constant. Then you have this new matrix, okay? And for linear regression, we use ordinary least square, the ordinary least square linear regression. So you can just call that's the statistics model. Okay, and you call the linear regression, and then you just plug in with the x and the y matrices. Then the model is going to be built. After the model is built, then you can fit the model, and then you can get the result of the model. Okay, and here it can give you the parameters. So parameters is regarding the B1, B2, B3 is regard, because we have 3 independent variables, the coefficient corresponding to the X matrices. And you can also get the summary information. Yesterday we also explained. So that's the plus part for the statistics models. Okay, so this is the plus benefit. And with machine learning model, it doesn't have this kind of statistics report. Okay, and it's quite helpful to give you like the R square. And yesterday we also said R square, if it's close to 1, then that means your regression model is good. Okay, it's good. And it also gave us, you see, the independent variable. That's it. And their corresponding coefficient. Okay, corresponding coefficient. So that is this model, basically you can write as x1 and then plus 0 x2 plus 050 x3. So this is the linear model, okay, based on that 100 sample data that you find this 3 coefficient, then you can have this model. Once you have this model, if you have new x1, x2, and x3 value, then you can use this equation to calculate y value. Okay, so that's how this model works. Okay, and you can also find some related statistics values. Information like p-value, generally speaking, if it's smaller, then it's good. Over here, the p-value is smaller. Generally it's like 0.5. And also, if you recall last class, we also said the sample data size should also be big enough, okay? And the last class is just 5 samples. That's normally we said that is not important, is it? And generally speaking, you should at least has more than 30 samples. Okay. Okay, so so that's regarding the studies model, the linear regression we just saw. And this part we already know, is that for data frame, you can also define columns, is that for some values. So here you define each column, okay, and you can also, for Y, you can also add a new column, okay, for the data frame. So nothing new in this. And the why we do that is for status model, is that you can also directly provide string-based formula, is it? So this is also, if you recall, the PATC package is also supported. And here then it knows, okay, I'm going to use the column name, is it, as the x1, x2, x3, is it, for the corresponding independent variables, okay, independent. And then you provide the data frame. So this is data frame, and then you call the fit model, is it? And you can also, after you do the fit model, you can collect all of the parameters and other statistics related information, okay, like t values. Okay, you can also do the prediction, is it? Once you have the model, then you can do the predict. And when you do predict, you can use new values. These are new values. These new values, so they may not come from samples. Okay, so you can use it to predict. Okay, so that's the basic idea. And series, we are going to ignore it. Okay, and what next one is, we are going to move to the scikit-learn. Okay, so sklearn package. This is for machine learning. Okay, used a lot, okay, for all of the machine learning, and it has quite a number of machine learning models, okay, very useful, okay, we will see. And so over here we have, so the Titanic in machine learning is also very classical data set, okay. For Titanic, like the alive prediction is based on all sorts of features, and the data set, and generally for machine learning, normally for data set, you have two data sets at least, okay. One is we call training data set. And we also have testing data set. Okay, so over here, you have training data set in a CSV file, testing data set as another CSV file, okay. And a lot of other times is you just have a single data set, is it? And then you can split the original, like raw data set, into certain percentage. Okay, maybe 70% to training, and then 30% to testing. Okay, so you're not going to use all of the raw data set for training, okay, because you also want to test if the model is good enough, is it? So anyway, so after we read, we get data frames. So here is a glimpse of our data frame. So you have passenger ID, survive or not, is it? And this is binary data. Is it binary data? And this is a passenger class, name, sex, age, etc., and ticket, and a lot of other information. Okay. And then let's see. And generally speaking, when you do machine learning, you first need to do a lot of data exploration and data cleaning work. Okay, because if there are a lot of null values, you need to find some way to handle it. Okay, so here we try to find how many null values in training and in testing, is it? And it shows, is it like for age? It has quite a number, is it? And for cabin, it also has quite a number of null values, is it? For some others, it has 0, is it? So it gives you some idea, okay? And then over here, then you need to do some data cleaning and data exploration before you train the model, okay? Before training, is it? So let's see. And for age, is it because there are a lot of null values, is it? And if you just exclude them, that may not be good for your model, is it? So sometimes when we do the null values, we can use mean value. Okay, the provided one, existing one, find their median values, and then we fill all of the net values with median values. Okay, so you can do this. And then for the sex, is it female or male? Is it? And in this case, we also want to do some number. And because for sklearn, and the same thing as a studies model. Okay, both needs numerical data. Numerical data. So that's why if you recall previously we learned with some categorical data, you need to use like a kind of like that get dummy, is it? To convert from string, is it, from categorical data to number, is it, to number. So here, like for this, we can also do check, is it true or false, convert it to number as 1 or 0, is it? Okay, so that also belongs to data cleaning, okay, data cleaning. And then let's see. Over here, we pick some features. The passenger class is a passenger female or not? Is the age, is it? And we put them to predictors. Okay, so we are not going to use all of them. We only collect, so use 3 features. And generally, when we discuss machine learning, so for the columns, normally we say they are features, okay, features. And for the predicted values, and in statistics, we call them independent variables, as independent variables for the column. And so that's regarding X, is it? Regarding Y, is it, we call them dependent variables, is it? And in machine learning then for Y, we call them targets. Okay, target. So anyway, so here we are going to select 3 features, so 3 columns from the original, is it? And we get off their values, is it? For training, for testing, and also for Y, we also needed Y, which column we pick survive or not, is it? Survive or not, it's 0, 1, is it? So it's binary, is it binary? Okay, so we get to the training, but for the testing, we are going to use it for the purpose of our testing. And to use sklearn, then let's see. So after you do some pre-processing, so data pre-processing. And the next part, you need to select a model, is it? And so you also need to import sklearn. Okay, so that's the scikit-learn package. So over here, because if you recall yesterday, we explained linear regression. Linear regression in statistics is used to find if the independent variable, is it impact dependent variable or not, is it has importance. And linear regression can also be used to predict values, is it? And for, if you recall, we also learned another, and it's between 0 and 1, is it? And it's based on the probability, is it? And here's 0.5, is it? So on the right side, no matter how the X values of feature, no matter how large the feature goes, is it? It will always greater than 0.5, is it? So we said it is true, is it? Otherwise, if it's go to the left for the feature values, no matter how small it is it? And we said it's false, is it? It's 0, okay? So this, we call it a binary value, is it? And the binary value, and we can use logistic regression, okay? And for the logistic regression in sklearn, in machine learning, even though it's called regression, it's not used like we try to see if the feature is important or not, okay? And this still belongs to the linear model, okay? So logistic regression is used for classification. So here the classification is what? Is survive or not. It's survived or not. It's a class, is it? This is one class, this is another class. Is it? So logistic regression is good to use for classification. Okay, classification. And in machine learning, it's one type of supervised learning. And to use logistic regression, is that you need to import logistic regression. Okay, you first need to create this model, create an object for this model. And then you can start to train. And to train, it's similar as statistics model, you call the fit method. And generally, when you call fit, you're using training data. Okay, so that's why here we provide X train and Y train, training data set, okay, to train the model. Okay, and here it gives us that logistical model some arguments as a parameters, and generally this C and for our machine learning class, we will learn in more detail and understand it better about logistic regression, okay, how it works. So this is called regularization coefficient, is it, or parameter. And it can be adjusted, and then helps if your model to improve the model accuracy. Okay, and some other things like a maximum number of iteration. Is it single class classification or multi-class classification? And this number of jobs is using one CPU or multiple CPUs, so kind of allow parallelization or not, okay? Because for machine learning, it involves a huge data. So if you can make use of parallel processing, it can speed up, okay, the training. And the penalty is also regularization, is it? And the solver, okay, so what kind of the gradient function you're going to use, is it? So a lot of argument, and at this point, we just starting the introduction about the model building, so we don't need to worry too much, okay? So that's more involved with machine learning. So after you call fit, your model is built, okay, is built. And then you can call predict. And did you see with testing data, is it? So with predict, you can plug in testing data. And of course, predicted data. Is it for the future? Is it kind of like you use a lot of faces to do facial recognition training? Is it after your model is trained, then you can use your model to do the real world application to do the face recognition, etc. So that's the concept. Okay, and you can get the predicted value. So this predict, you also have Y test, is it? And then you can compare this predicted and the test, is it? And this is a predicted top 10, is it? Survive or not, is it? And then you can test it against with the test data so that you will know how accuracy your model is. If each one matches, that means it's 100% accuracy, is it? If some is off, like here is 1 and here is 0, as predicted is 1, and the actual testing is 0, then it's some off, then the accuracy may be lowered to 95 something, is it? So that's and we can also here, how do you know the accuracy? Is it you can call the model data score, okay? Then it will give you the accuracy. So over here, it's regarding the training, okay? You can also testing with testing data, is it? So for our training model, is it the accuracy is about 80%. Okay, that's the accuracy, not that high. Is it normally we would like to go to 90, above 90%, is it? And because this is a logistic regression, or if you do linear regression or some other model, is it? And it also can give you the coefficient, is it? Intercept and coefficient, you can also collect that. Okay, collect that. And what this MS is mean square error. Mean square error. As it's to calculate the error, and you square it and find the mean value. Is it between the training, the predicted training and the training? Is it? And we did see that's the difference between predicted and the real one. As this is from sample. From samples, not a single value, multiple values. This is a predicted, is it? And the difference between that and then 2 to the power, is it? So it's the square. So this part gave us the error, is it? Then you square it, is it? And then you take the mean. So that's why we call mean square error. Okay. So you can also collect those information. And you can also do the condition check and find the mean. Is it? You can see this value and the score. It's the same. It's the same. Okay. And for linear, not for logistic regression, and sometimes you can also do cross validation. Okay, and if you want to do cross validation, then for logistic regression, you can import logistic regression with cross validation. Okay, cross validation is you will not just, so this is your original data set, is it? And you split it into training and the testing. And the cross validation, so you just use this block for training and the other block for testing. Okay, for cross validation is you will not just based on this single one. Okay, so you will have your original first define like this 7%, 30%, and next maybe you're going to move. So this part is 30% for testing, and then the training. Is it the remaining are training, and you can keep moving. Is it keep moving? Is it so? Over here, each time when you do, we call them various folds. Folds. Is it? And then for each of it, you can do the fit. Is it? And then do the prediction to find the score, and then you average all of the different folds score so that we can improve kind of accuracy. Okay, so that's called cross validation. Okay, so it's some machine learning concept. Okay, and then you can predict, is it? And in this case, the cross validation, we didn't specify. So by default, it's not. Okay, so basically this is the same as what our previous model is without cross validation. Okay, and if you do want, then you need to specify, okay, how many folds you want to have. Okay, and then what is the next one? You can also do the cross validation score if you want to collect. Is it? So here you do logistic regression model. So this is our model, is it? And then I want to cross validation score. Is it? How do I do it? You plug in the model with the training data. Here you specify we are going to use 4 folds. Okay, so 4 folds means that's your original data. You're going to divide it into 4 folds. Four folds. So this is the first time you use testing, second testing, third testing, and the fourth testing, and all of the remaining going to be the training. Okay, then you average that. But for each one, you will have the score. Is it you can average that, or you can pick the best one. Okay, so that depends. So anyway, so just to provide you, and also you can see if the different folds, the accuracy calculation, the difference is large or not, so that you can have a better idea about your model. Okay. Okay, so we finish our first note in this unit. And what is the next one? We try to see more about linear and logistic regression model, okay? And just keep that in mind, okay? Logistic regression is for binary data. The Y, we mean Y, okay? And not for other numbers, okay? And in machine learning, so this is for the status model. And if for sklearn, Then it's for classification. Okay, classification is 0, 1, is it? So still binary, okay, true or not. Does it belong to that class or not? Okay, and the first example, the data comes from UCI machine learning repository. This is a very classic machine learning repository. So there are all sorts of data sets and you can use them to do different kind of machine learning model training and testing, okay? And also test if you have some new model you want to try. So there are a bunch of data set, okay? So over here, what we are going to do, you can see with machine learning, you use pandas, NumPy, and for sklearn, you can also do some pre-processing, okay? And we are also going to do a lot of plotting, so PyPlot from Matplotlib library, okay? And we are going to do logistic regression. And for the pre-processing over here from sklearn, the model selection, and over here, not like that Titanic, the testing and the training data already split. And here we are going to do the testing and the training data split, okay? And we are also going to see various ways to do plotting using CBOM, okay? So let's see, and over here, we are going to use the bank data set, okay? And we are going to drop the null values. And here get some glimpse of our data. So you can see the data size, and it has total 21 features, is it? And over 40,000 number rows, is it? So data size, the samples. So basically this is sample of the samples, okay. And you can kind of get a glimpse called pandas header method, is it? And get a glimpse of the data. So it has 21 columns, quite a lot, is it? And we can see, and for the data processing, and if you take a look at the education part, is it? It's all string, is it? So, and over here for the education, and you want to know what type of education that shows, is it? And shows here, it's kind of not organized where, is it? So you want to do some data cleaning. That you want to group all those under some basic group, okay? And then what you can do is we can use NumPy's condition filtering, is it? And do the condition check, and then you assign it to basic, is it? For the education category, okay? The feature for education column feature, okay? And then over here, and because it's binary for the Y values here, and we also want to know is that each class, how many data they have. So here to give us, so you can use the value counts to find how many from 0, how many from 1. So here to give us some idea. And once you have this, you can also do some plotting. And here we use CBOM. That, and if you recall previously when we learned plotting, so here use CBOM, we do the count plot, okay? And the X value is from the Y, okay, from Y, so either 1 or 0, is it? And the data will be the counts, is it? So from the data, okay. So here it give you the counts, okay, the count. And basically, it's kind of show as a bar plotting, is it? How many belong to 0, how many belong 1, okay? And what the next one try to show us is based on 1 or 0, is it? You can also find the percentage, okay? So we can just do some manual calculation, etc., and can find the percentage. So that's nothing new, pretty straightforward. And you can also do group by, because it has either 0 or 1, and find the mean, for each different columns. And over here, we can also group by the job column, and then to give us some idea. So here it's just a lot of time before you start build your model, train your model, you also want to glimpse, explore your data. So here just shows us a different way so that you can get some idea about your data distribution. And you can also do group by the marital, and find the mean, group by education, and give you the different types of education, find the mean. And what is the next part? Try to show more visualization, okay? And the visualization, if you recall, previously we learned crosstab, in data wrangling and data aggregation. Okay, the crosstab is used to what? To count frequency. Count frequency so that you don't need to do like a group by and then count, okay? And you can directly call crosstab, and the pivot table, if you recall. They all support data aggregation, okay? So we call crosstab on what? We use job and Y, we pick those two features to do the frequency calculation, okay? And what do we plot? We use bar plotting, okay? And then you can see the plotting. It's quite clear, based on the binary, binary, and then show the different color of bar, and then the frequency, and over here it's regarding the purchasing frequency calculation, okay, based on the different job, different type of job. And within the job, it's also subgroup by yes or no, some other category, so that you can have quite a clear idea. And the crosstab we already see, and what next try to explain for the crosstab, you can also based on like marital and the yes or no, and what the next part try to do is, after you do the crosstab, you also want to find, so this gives you the pure frequency, the counts. And you also want to find the percentage. And if you want to find percent, you need to do the summation and the division, based on this column, or based on this data set, so here that's how we do it, and you specify the axis. You're going to do division by what? By row, and do sum of what? By column, because you're going to find the percentage, okay? So once you have those, and then you can also do the plotting, do plotting, and over here, the plotting, we still use bar, but we use stacked, so then you see, and based on that 0 and 1, and you stack them together instead of side by side, okay? So it's just give us more visualization, okay? And similar for education, and the why we can also do the bar plotting with stacked, okay? And the frequency also week of the day, give us some idea, okay? And what the next one try to show is, we also do bar plotting with the frequency, and this time it's regarding months and why, okay, and also give us the frequency of the purchasing, okay. So pretty straightforward with a bar. And you can also do histogram, is it? And this histogram is regarding what? It's regarding age, is it? And the frequency based on age group, okay. Okay, so, and what is the next one? It's based on some other outcome. Anyway, it's still do frequency calculation, okay. And what is the next one? Try to show, if you take a close look of this original data set, is it has quite a number, like a job, merit, education. You have quite a lot of categorical data. Is it for those categorical data, when we want to training, we need to convert them to numeric. Is it data? Is it? And how do we do that? Is it? So here it shows. So all this still belong to data pre-processing. Before you do training, okay, you need to do all of this kind of work. And then let's see. So in this part, what we are going to do is, if you recall, we can use get dummy, is it, to deal with categorical data. So this variable will loop through the column, is it, the column. So like for job, is it, and education for merit, is it, and for different category, and you can also specify the prefix, is it, then it will become like a job, and job maybe over here to some shows, is it? And job admin. This previously its value, is it? Now it changes to column, is it? Will be served as a new column. Then it will only take 0 or 1, is it? That's what this get dummy will give us, is it? Then we can use join to get all of them. So because your initial, you only have 21 columns, is it? After you do the dummy variable conversion, your column will be expanded, is it? So here it shows, it has quite a number of new columns, is it? But they are related with the previous, like either job, or entrepreneur, housemaid, retire, everything, is it, from the job. So here just shows us how do we do that, is it? And then, and for the job, the original column, then you don't want them to appear for your data, for your model training. So you need to drop original after the get dummy, is it, after get dummy. So how do I do that? So is that if it is not in the categorical data, is it, then you are not going to, you're going to keep it. Is it? Otherwise, if it is already, you're going to drop it, okay? So that's why you see job column doesn't exist anymore, as it has job underscore something, as it, or married to underscore something. So this is how we get the data column cleaned, is it? And then after that, is it, you can specify your independent variables and dependent variables, because over here we are going to use a statistics model, okay? And we are going to use a logistic regression here, okay? And then you can call fit, is it? And you can also get some summary information regarding the logistic regression, okay, for this model, okay, for this model. And why we use a logistic? Because the dependent variable is 0 and 1, is it? The binary. So that's why here you pick a logistic instead of linear, okay? And then you can get a lot of useful statistics information, is it, regarding this model training. Okay, so that's for this second note. We are done. Okay, and Friday we should be able to complete this model building part. Okay, so that's all for today. So I will see you all on Friday. Bye.